So let's talk about the discovery of fire. But here's the twist. What if it wasn't an accident at all? We're going to explore how the unique chemistry of our planet, combined with the basic needs of our earliest ancestors, made a relationship with fire, well, inevitable. And it's a relationship that changed absolutely everything.
I mean, really, try for a second. No cooking, no cozy warmth on a cold night, no light to push back the darkness, no metal, no engines. It's almost impossible, right? And that's because fire isn't just one discovery among many, it's the very foundation our entire world is built on.
All right, here's our game plan. We'll start with the science, the inevitable spark, then we'll see how we started taming a natural force. After that, we'll tackle the Great Ignition Challenge, witness a world forged by fire, and wrap it all up with a cool thought experiment. What if fire was different? Let's dive in.
Okay, so before we can even talk about humans, we have to talk about chemistry, because long before we showed up, the universe had to set the stage. To really get why the discovery of fire was so important, we first have to understand what fire actually is.
You know, when you break it down, it's actually pretty simple. Fire is just what happens when oxygen gets together with some kind of fuel, like wood. And the thing is, those two key ingredients, oxygen and fuel, are literally everywhere on Earth. For millions and millions of years, they were just sitting there, waiting for a spark.
And this quote, it gets to the heart of our whole story today. The journey with fire wasn't some random series of lucky breaks. It was a sequence, a puzzle that could only be solved in a specific order, dictated by the laws of physics and the needs of early humans. It was bound to happen.
So what was the very first piece of that puzzle? Well, long before we could even dream of creating fire, our ancestors had to learn how to live with it. This wasn't an age of invention, it was an age of pure observation.
So picture it. A lightning strike hits a dry forest. A tree goes up in flames, and instead of just running away in terror, a small group of Homo erectus gets curious. They creep closer. They feel its incredible warmth. They notice how it keeps the big predators at a distance. And then, the big realization. They can feed it. They can keep this amazing thing alive by giving it more wood. This was step one. Not making fire, but capturing it from the wild and taming it.
Now look at this timeline. Just let that sink in. For nearly 500,000 years, 480,000 years, we knew how to use fire, but we were completely at the mercy of nature to provide it. If your tribe's precious flame went out, that was it. You were back in the cold and the dark, maybe for generations, until lightning decided to strike again. So what on earth made that next step so impossibly hard?
Well, it all came down to one single problem: ignition. How do you create that intense, concentrated burst of heat out of thin air whenever and wherever you want? For thousands upon thousands of years, this was probably the single greatest technological challenge our species ever faced.
Let's break it down. Using fire is pretty passive, right? You find it, you feed it. But making fire, that's an active process. It takes knowledge, it takes finding just the right materials, and it takes following a series of complex steps. You can't just accidentally stumble your way into making fire. You have to engineer it. And that is a huge leap, from just using the world around you to actually controlling it.
And here it is. This was the game changer. Somebody, somewhere, figured out that if you smashed these two specific types of rock together, flint and iron pyrites, you could create a spark, a tiny little star that could catch on a piece of dry tinder. I mean, can you imagine the moment of that discovery? It was probably difficult, super unreliable, but for the first time in human history, we didn't have to wait for the sky to give us fire. We could make our own.
Over time, the technology got better. Things like the bow drill came along. You'd use a bow to spin a stick really fast, creating an incredible amount of friction and heat. But just look at the effort. This wasn't as simple as flicking a lighter. It took skill, it took strength, and it took having perfectly dry materials ready to go. It's a great reminder that for our ancestors, fire was always hard won.
Okay, so once we finally cracked that ignition problem, everything, and I mean everything, changed. Having fire on demand wasn't just a small upgrade, it was a full-blown revolution that completely rewrote the rules for human society and our place on this planet. The moment we could make fire whenever we wanted, it was like a dam broke. Suddenly, we had warmth in the cold, we had light after the sun went down, we had a powerful shield against predators, we could cook our food, which made it safer and gave us way more energy, we could harden the tips of our wooden spears, explore the deepest, darkest caves, and eventually, this mastery became the foundation for everything from pottery to forging metal. It was an explosion of possibility. The overall impact was just profound.
Fire is what allowed us to leave the warm climates we evolved in and spread to every corner of the globe. It completely changed our diet, our social lives, our power. When you get right down to it, controlling fire is what turned a clever ape into the planet's dominant species.
All right. To really appreciate how perfectly suited fire is for us and our planet, let's do a little thought experiment. Let's just imagine for a second that the basic laws of chemistry were a tiny bit different.
So think about this. A normal wood fire burns at around, say, 800 degrees Celsius. Hot, but manageable. But what if that same simple fire, the kind you make with sticks, naturally burned at a scorching 2,000 degrees? How would that one little change completely alter the path of human history?
The answer is wild. See, we had a Bronze Age first because the metals involved, copper and tin, have pretty low melting points. They were achievable with early fire tech. Iron, on the other hand, needs way higher temperatures. But if a simple wood fire was hot enough to smelt iron from the get-go, we might have skipped the Bronze Age completely. You could have Stone Age people running around with iron tools and weapons. The entire timeline of civilization would be totally rewritten. It just goes to show how deeply our story is tied to the fundamental, unchangeable laws of chemistry.
And that kind of leaves us with one last big question to chew on. The story of fire was this series of inevitable steps, right? It was driven by need and shaped by the laws of nature. So what about today? What fundamental force, what new technology is our generation just beginning to tame? And is its impact on our world just as inevitable and just as revolutionary as that first controlled flame? Something to think about. Thanks for joining me on this